Inshallah. So today we'll continue our lecture with. We actually begin the content of statics in this lecture. We cover chapter 1 and part of chapter 2, inshallah. By the way, anyone who just joined the class, meaning was not here in Tuesday? Okay, so everyone is here on Tuesday. Alright. Okay, inshallah. Bismillahirrahmanirrahim. Rabbi zidni sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, bismillah. So in chapter 1, basically we will just introduce mechanic statics and just refresh most of the things that you have learned before. That will be fundamental to whatever we do in engineering in general, basically, especially in mechanics and statics. Alright, so the objective for this part is for you to be able to understand what is statics, and then this we will cover refresh about the units, the rounding off of figures, and also problem solving strategies. So what is mechanics? Anyone know what is mechanics? This is not referring to the one that you call when the car is broken. So mechanics is basically a study of what happens to a thing when forces are applied to it. Right? So the technical term that we use is body. So for example, if I want to analyze what happened to this when you have a force, so this will be considered as the body. Right? So that's the word there. And forces, I think you know what forces are. Right? So what we deal with is anything that is under the application of force. That's basically it, right? So when force is applied, what happens? And the object can be small, big, different types. So if you can see this one, this is like some, I'm not sure what this is. That object is hanging from the chain. For example, this is the wheel of the train on the train track. So any case where there's interaction of forces, etc., so that can be considered as part of the analysis under mechanics. Right. So mechanics is quite big because any object can be applied force to. So the type of object can be rigid body, deformable body, or fluids. Right. So things like this is rigid body, meaning it doesn't change in size, shape, etc. That's the easiest to deal with. And then we have deformable body. Maybe this one, this is deformable, right? It can deform. And then the most complex is fluid, because fluid, when it flow, it follow the shape, and meaning the flow is complex, right? So the easiest one is here. The most difficult, challenging is here in terms of analysis and calculation. For those who are going to be majoring in mechanical, you will be studying throughout until your fourth year will deal with this one. For those who are not in mechanical, then you will be until up to this one only, right? You only take static and dynamic the first year. Alright, so those are just an idea of mechanics. Right? But make sure you understand this, especially for the mechanical student, because this will be the fundamental for. If you cannot even deal with this one will be too much to handle, right? So it's and also you have incompressible, incompressible. You will deal with that one later. Unit of measurement. So in engineering we have this unit of measurement. We have physical quantities of length, mass, time, and force. I believe you have covered this one before. Newton's second law. I think you already know F equal to m times E. And yeah, so this is just to refresh. And we will be using the SI unit. In the world today, there's two types of unit that's being used. One is the SI unit, where you have kilogram, Newton, meter, etc. And you also have the other system, right? If you watch American movie, they normally use feet, inches, like that. Right? So those different. So what we will be using normally is this one, right? So for length, we have the unit of meter, time, second, mass, kilogram, and then force we have Newton, which is basically, this one can be derived from the Newton's second law, right? m equal to F equal to m times A, m kilogram, acceleration is just meter per second square, right? So it will become like this, kilogram meter per second square, that is equivalent to Newton. Alright. So in terms of the usage of SI unit, there's no such thing in plural. It's not 1 kilogram, 5 kilograms. This is not English. So kilogram is kilogram. And then if you have to separate two different units, it should be different. It should be like that, m dot a. Now, just to refresh, I think I did mention before in the previous class that, okay, we went before that. Normally, in dealing with this subject, I try to fulfill both aspects. One is for those who actually want to become an engineer and want to understand the basics, etc. So that's one angle, right? I want to understand why is this like this, etc. So that's to understand the fundamentals. And the other part is I just want to pass my exam. So that's another one, right? Some students only want this one, some students want both, right? So I try to cover for both. Now, but the assessment is modeled to be as close as possible to the understanding level, right? So as I mentioned before, the mark that you will get is directly proportional. It's not directly proportional. It's not directly proportional to what you understand. I mentioned that, right? But it's directly proportional to how you present what you understand, right? So even if you mean to say the correct thing, but the way you write is not correct. For example, this one is not the same as this one, right? What does this mean? Millisecond is meter second, right? So you cannot say why I lose so many marks. Dot je, sir, ni dot je. No, the meaning is totally different, right? You cannot say just hilang satu dot, patut hilang 0.1 markah. It doesn't work that way, right? Because the meaning is totally different. So that is what we mean by this like that, right? Okay. So this is how it is written. Now, that's exponential. So for example, centimeter times centimeter becomes centimeter square. Now, I believe you understand what is the meaning is centimeter, millimeter, kilometer, etc. and what happens when you multiply like that, right? But make sure, because I think many students make a mistake when there's a compounding or there's exponential power like that. For example, if you change from meter to millimeter, right? It's straightforward. What do you do? You multiply by 1,000, right? But if you have this to this one, what do you do? You cannot. This is not the same conversion, right? Because there's square there. So in the exam, in the previous exam, some students actually make a mistake here and it becomes totally wrong in terms of the answer. So make sure you understand what happens when you have square, cube, or power of 4, etc. and how to convert. Right? Meter to millimeter and meter square to millimeter square is not the same conversion. So make sure you understand that. Compound prefixes should not be used. This is quite interesting also. I think another how to say? For example, if you have millimeter, right? I forgot what is exactly the student mistake, but it's such a way that if you have 1,000 millimeter, you cannot say it becomes 1 kilo millimeter. It doesn't make sense. You understand? Because it is 1,000 is 1 kilo, right? You cannot say this doesn't make sense. What is this? Right? So make sure you understand that it doesn't make sense, because this, if you write something like this, it shows that you better not become engineer. Okay. So in terms of prefixes, so basically, I think you know all this already, right? So if you write in terms of the exponential form, or what is the symbol for these prefixes, right? So you have giga, mega, kilo, milli, micro, nano, etc. Right? Of course, in static, normally we don't, we rarely see this level. but in, for example, in electrical, etc., maybe you reach this level, or in bio, for example, when you go to small. Normally, when we deal with structure, it tends to be higher and higher, right? But you should know this regardless. Okay, numerical calculation. So you must have dimensional homogeneity. Dimension have to be the same both sides, right? You understand homogeneity, right? Kita homo atau homo? Tak ada kaitan dengan Yesus masa. But it's the same. It's homogeneous, meaning it's the same. It's basically, yeah, in layman term is the same, right? So on both sides. So this is another thing where how you write means something, and if you have to write properly, right? So if you, so meaning what happened if you have equal sign, what happened here should be the same as here, meaning in terms of unit, etc., it should be the same, right? And also, okay, just mentioning about this, in terms of exam, right, if you write something like this, and then something like this, and then you have something like this, and then something like this, right? What do you understand to be here? It follows from above, right? What here? It follows here, right? So, if, for example, in your calculation in the exam, you forgot to write M here, right? What will I understand here? We will understand this is F, right? And do not be surprised if you totally get it wrong here, because it's no longer F, for example, right? So, you cannot say, lah tak tahu answer ni kan M. So, because we only can, in terms of the assessment, we can only judge based on what is on the paper, right? We cannot. No, I think your intention is ikhlas kat sini, dia tak boleh nak judge the answer like that, right? So even though we can guess you make a mistake and you want to do something, but we can only go with what is there, right? So similarly in this case, so that's okay. Use an appropriate number of significant figure. You know what is significant figure, right? 3 for answer, at least 4 for intermediate calculation. Do you understand why? You know what is the answer and intermediate, right? So normally the answer is, for example, M at the very end. Let's say M equal to something. This is the final answer. But you have all the calculation before, right? So the statement says that here it should be 3 significant number, significant figure. Significant figure. This should be at least 4, meaning 4 and above, right? Okay, for this one, do you understand why? Why it should not be less? Yeah, if you run off too much in your calculation, then the error will be big, right? So it should be, the more the better in that sense, right? What about this one? Why should it be 3? Why cannot it be 4? 3. This is not at least 3. This is 3, not more. Why cannot it be more? This is normal, general. Right? Because in some cases, normally we sometimes accept, but normally, if you, okay, if I say, do you know how much you weigh? Okay, that's math, right? Not weight, right? Normally we use, okay, math, right? 7, let's say 60. If I say my mass is 65.31253 kilogram, right? Is there any problem with that? And what? Ini berat sangat ni, banyak makan. No, in terms of the number. Now, if I ask and someone asks this, the big question is, how do you, is there any measurement that can give you this number? It doesn't exist in the real world. Right? So that's why normally the measurement that can give is 3. Right? So if this is differentiating between engineer and those who just calculating stuff, right? If you calculate, obviously your calculator will give you the number. But when you represent in terms of engineering concept, this doesn't make sense. How there's no way to get this one, right? In real physical world, right? So this is why normally it trains you to go to that direction, right? So the final answer will be in that level, 3 significant figures. How to round off, I believe you know, right? More than 5, it's more than 5, right? Alright, concept quiz. Skip the name. Now, problem solving strategy. So this is okay, by the way, I forgot to upload the slide. Inshallah, I will do after this, right after this, so all the slide will be on iTalink, inshallah. So in terms of problem solving strategy, there is 3 approach to IPE. This applies to any engineering problem actually. And sometimes we do not appreciate some of the steps because we can jump the step, but in engineering problem, as you will discover later on, it becomes very important, each of the steps, when we deal with more and more realistic problem. First, to interpret, read carefully and determine what is given and what is to be found. So this is the first thing. In the exam also, if the first thing you have to do is, okay, what is the question give? Okay, give this one, and what the question wants. If anything on that is not clear, make sure you ask. Right? If necessary, make assumption and indicate them. Okay. The assumption and indicate only comes normally in static in the later chapter towards because normally in the earlier chapter we cover in a very basic and very straightforward. So every calculation is straightforward. But there will in engineering world there's no question that can be answered straightforward. You have to assume and you have to test the assumption normally. So yeah, this is because it's quite complex. If you do not assume, you cannot actually move forward in your calculation. Normally that's the nature, right? You will notice this in later chapter, in chapter 6, 8, 9, 10, something like that. Right? This doesn't mean that you assume something that should not be assumed. Meaning if something is given, you cannot assume something else. Rasa boleh kot. No. This is assumption when something is not given and you have to start with a certain assumption. Right? The worst assumption is, let's say ni linear. If you assume like that, you will see me again lah. Next semester. Okay. Then you plan. If you understand that already, then you plan what is the major steps, a roadmap, and then you will have to solve. So you have to plot. Okay, this is given. This is the final answer that is needed. How to get there, right? I will determine this one, and then I can calculate that one. For example, think of alternative creative solution and choose the best one. Okay, this is also more related. In real world, this is definitely applicable because there is more than one way to get to the answer. Some will be longer, some will be shorter, some will be more complex. This will also become a reality in the later chapter where you have, if I go this way and I go that way, sometimes one will need 1 page, one will need 3 pages. So if you do not think beforehand, you might waste too much time in your exam, for example, right? So this becomes crucial in the later chapter. When we say alternative creative solution, meaning how to solve, not creative way to refer to the solution manual, not that one. Right? Macam mana dalam exam nak refer solution manual, itu cerita lain lah. So hopefully you are not. We have to talk about Toyo semua last class, right? And then you carry out your step, use appropriate diagram and equation. And normally in the exam we do this diagram and equation do carry weight and marks, right? So if you have your diagram or equation in your head but you do not put it on your paper, sometimes you will lose your mark because of that. Estimate your answer, avoid simple calculation mistake. In terms of calculation mistake, normally it comes with practice. If you never practice, you will never know where you tend to make mistakes. Yeah. And then reflect on and then revise the work if necessary. So reflection is one tool that should be beneficial for basic mistake, I think. For example, let's say we have a question where, let's say this river is given, then there's a raft to transport say elephant from one end to another end, right? And then you have to calculate what is the maximum weight of elephant that you can transfer with this given size of boat, for example. And then you calculate, and then you say, it's 65.3, blah blah blah, right? So if this is the answer of that question, is there any problem? For that sense, no, I'm not talking about your weight. No. I'm talking about you have a river, and then you have a raft. You know raft? Yes. Or a boat, for example, to transport elephant. You know elephant? Yes. Okay. From one end to another end, right? And then after you calculate, you say, this is my answer. Is there any problem? You should know that, okay, how come elephant weigh as much as me? This is the problem, right? So there must be some mistake here. If you say confidently, yes, this is my answer, sir, I will confidently say you are not fit to be engineer also. Because it doesn't make sense. So some mistake in the exam can be, you can detect by simple reflection. But some cannot. If the mistake is just a small bit, normally it's hard to detect. But if the answer is ridiculous like that, then you should know, okay, this doesn't make sense, right? Okay. Attention quiz. Okay. For static problem, your calculation show the final answer is 1, 2, 3, 4, 5.6 Newton. What should you write as your final answer? Which one? A, B, C, D, or E? Any of you say A? B? C? D? E? Why D? Yeah, 3 significant ways. Right, okay, this is the reason why, if you see the textbook, they normally, sometimes people, maybe you would ask, why they change the unit? Right? Because this is okay, right? So, this is because of the 3 significant figure. So, they change the unit so that this will be it can be expressed in 3 significant figures. You cannot change here to become 1, 2, 3, 0, 0. That is wrong. That is not rounding up, that's changing the number, right? But if here 1, 2, 3, 1, 2.3, 4, 5, then this is rounding off. Right? So, yeah. Okay, this is just if you memorize, right? It's the 3-step IPE, what is P? Plan. Alright, so that's the end of chapter 1. So nothing much there, it's just to have you to feel like, oh, macam senang ni static. So we'll go into chapter 2, where we will be dealing with vector, right? Now, vector also is something that you have learned before, right? So most of the thing here is something that you have learned before. It's just that we'll refresh on some things and we'll test whether it is still fresh with you or not. And if not, hopefully what we'll cover will push you to actually refresh on what you have covered before. Because what we'll cover in chapter 2 and 3 will be very fundamental. Basically most of them you have learned before, but it will be something that you should be able to solve with no time. Meaning you can solve that like that. If you take too much time to solve anything here in chapter 2 or 3, because this will be the first step in the long step in later chapter. So if you struggle with this one, then you cannot solve. You don't have the time to solve the rest of the solution in the later chapter. Right? So, right. In this part, we will deal with 2D. You know, the 2-dimension and 3-dimension. So we always start with 2-dimension. And all right. So now this is an example of why we apply vector, right? If you can see, there's a chain here, several chain, and then a hook in the chain. So if you want to know what is the force in each chain, etc., you have okay. In any problem like this, you have two options: whether to use scalar or vector, right? Normally, you can Not normally, but normally it can be solved with both. But normally it's very easy, relatively, to solve using vector. So that's why we learn about vector, because especially when we go to 3D. In 3D, if you want to use scalar, normally it will take too much paper to solve, right? So in vector it will be quite short. So that's why we learn about vector. Okay. Now, what's the difference between scalar and vector? So this is just the example. Mass volume is scalar, force and velocity vector. So the difference is scalar only has magnitude. For example, what is the mass? Is 60 kilogram, right? While vector have mass, magnitude and direction. So it's 30 Newton in that direction, right? So the effect is that when you want to add, so for mass it's just, if you have 5 kilogram and 5, it's just 10 kilogram. It's simple. But if you have 5 Newton and 5 Newton, you have to know where's the direction. You cannot just simply become 10, right? If it's 5 that way, 5 that way, it cancels each other, right? If 5 and 5, you have to know, okay, it becomes some angle there, right? So you have to use, in the simplest form, is parallelogram law. Now, in terms of the way we write, also is different. This one is just write as is, meter or what. But this one, there's a way. So just to check how normally you write, right? Because for force, for example, this is a scalar. This will be vector, right? And this two is not the same. Do you normally write like this, or is there any other different way that you learned before? This way, right? Okay, but in the textbook or in the slide, you will never see this one, because normally in computer it will be like this. It's kind of bold and sometimes italic. Right? So if you refer to the book, you will see that it's actually bold, and in the exam paper also it's a bold letter, right? So you have to understand, when you write on paper, we do not expect you to write like this. For several reasons. One is it can be ambiguous, meaning you intend to write bold, atau you tengah stress, tengah tensions, or your pen is having a problem, or it becomes up to interpretation, right? So normally we say it's like this, so it's clear, right? So if you miss that arrow, you mean a scalar. So going back to the homogeneity just now, if you mean to say a vector but you forgot the arrow, then it becomes not homogeneous, right? Because on this side is the scalar and on this side the vector, meaning the numbers, right? So those will cost you significant amount of marks. Right, so in the PowerPoint presentation, it will be like this. Right? So bold. Sometimes the color is also different, red color like this, just to differentiate. So, but in the paper, then we expect you to write something like that. Alright. Vector operation. Now, if you have, of course, this is still refresh, so something you have learned before, right? So if you have vector A, a vector with magnitude A, so 2A becomes twice the length. Negative A is the opposite direction. For example, here it have half the length and opposite direction, negative 0.5A, for example, right? So all of you understand already this one, right? And then if you want to add, you have the parallelogram. You understand what's happening here? Right? Basically, if you have two vectors, let's say vector A and vector B, and then AB, say this A, B. So if you have R is A plus B. Now notice that this one, if you write like this is wrong. You understand why, right? Because when you add the vector, it's correct, but when you add the magnitude, it becomes something else. It's not become R here. Right? So what you do is basically parallelogram is basically you start at the same point. So you have the two vector, and you draw the parallel with this one and parallel to that one. So at the meeting point here will be R. Okay, so that's basically parallelogram. Right? And of course, other than this, you can use the triangle also. The difference is basically the same thing, right? But the difference is parallelogram is you start at the same point and you add the parallel line and you make the point, right? If you have the triangle, so if you, for example, you start with A, at the end here you add B, and then you get R, right? Or you start with B, and then here A, you get R. All of this should give you the same answer, right? But normally in static we never do this, because this is only applicable for two vectors. If you have A, B, and C, you have to do step by step. You have to solve A and B become R, and then R and C becomes the full R. So if you have 4 or 5, then it's too much, right? So, but we do this just to understand the concept. Second reason why we don't do this, because this requires you to have an actual accurate, because you have to, the length have to be accurate, the angle have to be accurate, right? You cannot just sketch, because sketch, one student will sketch like this, parallel here, it will be a bit lower. Some student will have something like this, parallel here, it will be up a bit higher, and it will mess up. And the length also, so it has to be actually exactly accurate, right? So we don't do this in the real engineering world, but this is important concept for you to understand and be able to visualize, so that you can understand what comes later when we deal with vector, right? So how do you subtract vector? For example, A minus B, what do you do? If R is A minus B from the same AB here. Yeah, it's basically just you have A. If you use then B, the negative B will be like this, right? So if you parallelogram, it will be something like that. Betul ni? Yeah, minus B here, right? Right. So, and if you have A plus 2B or A minus 2B, etc., then you know what to do, right? So, alright. Now, resolution of a vector or resolving a vector, right? This is basically the reverse step of this. If you understand what's going on here, it's basically just the reverse. For example, okay. In this case, okay, for this particular drawing, right? If you go from the right, we have two vectors. If you have A here and B here, how do you get how do you get the resultant of adding these two? You do the parallelogram, you'll get right. This is different where you have one force. How do you get the component in that axis? So what you do is also you do the parallelogram. This is parallel to this axis, this is parallel to the axis, and this will be the two component. So it's basically the reverse. Right. So you should know how to do this also. Right. You understand? Normally what we do here, okay, why is this important? Because but normally we do this without realizing, because normally what we resolve is in terms of x and y. Right? So we actually apply parallelogram, right? Because it's parallel, and then this is the component. This is x, the y component, right? So you need to know how to resolve forces. But sometimes the question gives a certain axis like this, so you have to follow, this is the axis and how to deal with this one. Right? So that is resolving a force or resolution of a force from one vector to become two components. Any question? Alright, so when you have addition of a system of coplanar forces, before that, do you know what is coplanar? Never heard that before? Mana tu? Oh, tak ada. Coplanar meaning basically it is the same on the same plane. Tahu kan? Kebetulan ada beli tiket kau terbang sama, dia on the same plane. No, you know what is plane, right? For example, this is the plane. So if every force is on this same plane, it means it's 2D, two-dimensional. Right? Because if 3D means it's something is out of the plane, right? Okay, so coplanar is basically two-dimensional. So how to deal with this one? So basically, first we resolve the vector into the component using x and y. So you know how to do this one already, I think. This one, and then resolve into x and y. Each of the vectors show magnitude and direction. Okay. You are familiar with this I and J, right?
Yes.
How do you normally write it? Because let's say just now for F we write like this, right? For I, how do you write normally? Atas bawah. Ada yang macam ni? Bukan? Macam ni? Any different way? Macam ni? Ada ni? I biasa macam ni? Okay, now you have to understand that this, because if you see here, it's basically red, slant, and bold. Meaning it's a vector. This is actually a vector. So if you in here, if you write something like this, then it's wrong because this doesn't indicate it's a vector. So if you write any of this, I can accept lah. Normally this one is quite good because this one have a different meaning in different chapter. Right. But this one or this one or this one, I think I have seen it before because different institutions have different way of teaching. So I can say as long as it's now normally I and J, normally there's not that much confusion. That's why some people just bagi jalan. But when you have K, right? In 3D you have K, right? This have to be different than this because this is kilo, this is vector. Right? So the meaning is different. So to be consistent, this to be arrow or any of this should be okay. You understand? In the slide, you might not notice because it's written like this. This means it's bold, so it's vector, right? So the way you write on paper should indicate clearly it's the vector. I'm not sure if you notice this one. This is bold, this is not. Maybe it's hard to see from afar, but if you see the textbook, it should be clear. So that's why the way you write have been different here and here. Okay, that's the first step. When you want to add, before we can add, because we can only add on the same axis. So that's why we just say, okay, resolve everything in x and y so that we can add easily after that, right? So this is resolving. So an example, if you have f here, you get fx and fy, so it becomes fxi plus fyj, right? Notice that this is bold, this is not, right? So in our case, for example, you can write something like f equal to fxi. I haven't a habit to use everything arrow, so I write like that. But if you write anything, that's okay. Right, so vector, scalar, vector, scalar, vector. Right. And if you have done something like this, okay, the axis can be slanting also, right? For example, this is x, this is y. So if this is f, so x component is here, y component is there. You notice that y component is negative direction, so it will become like this: fxi minus fyj. Okay, normally we have x and y is vertical and horizontal like this, but in some cases it's easier to have slanting when, for example, if the ground is like this. So if you use x and y like this, it's more difficult to, because there's more angle becomes in the picture, right? So you just might as well just use that ground as the x, for example, right? So yeah. But x and y must be perpendicular. Right. This is the convention. You cannot say you simply have an angle like that. Okay. So if you have multiple force like that, if you want to add, first you resolve into x and y. So meaning that, for example, for f1 we have f1x and f1y. For f2 x and y, f3 x and y. So after that, you can just add all the x component and add all the y component. You have done this before, right? Yeah. So this is just a refresh. And then you can get the magnitude and the angles. Right, so from the original to become the x and y component, and then in the end you get the resultant of x and the resultant of y, I and j. If both is positive, for example, so the resultant is positive and positive, the resultant will be this one and the theta will be that one, right? Okay, so what is important here is if the question gives you several vectors, several force in vector form, no, it's not several force in different directions. So the easiest way to solve it is by using vector like that. So you get you resolve into x and y component, add the x component, add the y component, you get just the resultant of x and y. Depending on where it is, you know where the theta is, and then you calculate this one. The answer is only complete, for example, if the theta is clearly shown where the theta is. If this diagram is not shown, it's not clear where theta is, right? It can be quadrant 1, 2, 3, 4, right? So that's why, for example, if you, some students like to refer to the solution, sometimes the solution, when they do not draw, they, for example, in this case, they will show like this, or something like this, to show that it's this angle, not this angle, not this angle, not that angle. But for me, it's easier just draw this one, it's clear. So this just to say that if anything missing, meaning it's not clear where the angle is, then your mark will be missing also. Any question? Yeah. Okay, so everyone understand, so take 5 minutes and let me see whether you can solve this one. Given you have 3 forces there, F1, F2, F3, you need to find the magnitude and angle of the resultant force. Alright, so 10 until 47. Okay, try to solve that one and see whether you have any problem or not. minit. Siapa? Okay, I think it's already 5 minutes. How much have you done? Ada yang tengah lukis lagi soalan? Okay, relating back to the problem solving strategy, IPE. The first one, do you have any problem to interpret what's the given, what is already given, what is needed? So what is given is the 4 forces and the angle given, right? Okay, what will be the final answer? From, if you read the question, what is the final answer should be? FR, is it? Anything else? And theta, right? Anyone do not even know this is the final answer. So this should be the first, meaning just the first step is to understand, okay, this is the final destination of this solution, right? So we need to establish this one, right? Now, what will be the steps then? When you plan, okay, so given are those 3 forces, the value magnitude is given, angle is given. What will be the step after that, until here? So you resolve force. So you can express in terms of vector, for example, F1 equal to what, F2 equal to what, F3 equal to what, term of x and y components, and then you can add, you get the x component, and then you get the magnitude and angle, right? So you should be able to map out the parts. Okay, resolving this one, any problem? F1. What's x component? 0i, y component? 300 g. Anyone have a problem here? No one. F2, what's x component? F2 is here. What's x component? Let's say if you from the calculation is minus. Is it minus?
Yes.
Then plus 450 sine 45 degrees 0. Any problem there? No problem. What about F3? 600? Oh, so, okay, anyone know how to use the triangle? If you use the 600 cos, what, 50 something there, what do you get? And then you come equal to? 360, right? Now, okay, we mentioned about this for a little bit. Now, the type of angle that you will be given, one is, it can be given in terms of degrees, right? One, it can be given in terms of the triangle, right, the ratio. So, this one is straightforward from, if you know the similar triangle, right? If you have the ratio there, right? So if you have here 3, 4, 5, and then this is 600. Let's say this is f3x, f3y. By the same ratio, for example, this horizontal over hypotenuse should be this f3x over 600, right? So if you rearrange, simply f3x is 600, 3 over 5. And this one will be 4 over 5, right? So now make sure you can use this straight away for several reasons. One, if you convert this into theta, because there's a 3, 4, 5, there's what else? 5, 12, 11, 12. But there's several ratio that they can give, right? If you change to theta, if you calculate, it's actually there's several point, blah, 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 and you tend to round off, right? And then when you cos that theta, you can round off again, right? For some cases, coincidentally, it doesn't affect that much, but some cases it can affect quite much, especially after that you multiply by several hundred, etc. So the number of error can be quite big. One of the things, which is why I do suggest you know how to do this one. Plus, it's straight away, and you plug in, the error is 0, and it doesn't even involve. If you convert to this one first, it already add another step actually in terms of time. That's number one. Number two, when you do in 3D, when you have this type of triangle in 3D, then you want to convert like it, it will make your life quite miserable. Might as well you know how to use this straight away, right? Because this is still 2D. When you convert, it's still simple, it seems, right? But when you do in 3D, then you have it's in the 3D space, and then you have to know how to do this one. You should be able to already convert, meaning do something like this. Otherwise, your life will be quite miserable. And do understand why we cover in chapter 2 and chapter 3. Normally, in later chapter, it's this, if the solution is like this, is the first part. So if you already have problem here, then it will, your life will become more and more miserable there. So make sure you know how to do this one, right? Now, okay, that's with regard to that one. So you really have to know how to deal with different these two type of angle, whether it's given as angle and then the triangle. Now, FR is simply just, if you add up all this, you'll get here, right? And you add up all this, you get this one here. So you get this one I plus this one J, right? And in this case, it will become, if you have calculated this one, you can check the value. It is this one, right? 41.8 and 1098. What that means is the x component is 41.80, the y component is 1098. So FR is here, theta is here, and you can calculate as such, right? This is Pythagoras. This one is just tangent negative 1. Right? And that will be the answer. Any question? Macam ni? Betul macam ni? Tak ada masalah. Oh, macam dia, you tak. What do you mean? You mean you jump the step ke apa? Okay, no, that is more of how you present your calculation. Because ada yang akan buat macam ni, summation of fx dicampur, summation of fy dicampur, and then you plug in the sini. So any of those, as long as the step is clear, it should be okay. Now, okay, in terms of that, some of the calculation will be quite obvious in the sense that if I structure like this, and then this is simply you calculate, you plug in here, then it's quite understood where this value come from. That's number one. The issue is the underlying meaning is that to get this one, you actually do the summation of fx. This is fx, and then you get here, right? And you skip that step. Now there are two type of step. One, there's obvious step like that. Those are steps that is crucial for you to show. For example, if you do not even show this one, then there's a problem. But for the obvious step like that, if you make a mistake here, for example, the value is not correct, the mark for the step is missing. If you do like this, right? If you write the step, but something wrong happened here, which you give this one. This one shows that you know the step. There will be half mark for this step. So those are the two things. So for example here, if you get the value here, you do not even show this one. That is a crucial thing missing in the sense that the meaning of this is not clear. That's not the issue of this step like this. You cannot say, lah, okay, kalau dia positive. No, you should still show that you understand what's going on. But things like this, it becomes the obvious step that even if nothing wrong happened, then it should be okay. Even though you do not lump in terms of the that first line here. Okay. But if you do not structure like this, it's quite different. Meaning, because what is the thing should be obvious to you. This is what we are talking about exam assessment. What is it should also be obvious to the examiner. If you structure like this, if the examiner want to see what is going on, it's easily understood. If you read F1 is somewhere else and there's different page, suddenly you get the value here, then it cannot be followed. So that is not acceptable. Because then there will be assumption. Okay, where does this come from? Itu orang sebelah ke? Apa ke? So there will be. Ada question ni? Okay, let's go to this one. Alright, so let's see. Okay, now before we go to this one, now the purpose I give you the time to, I give you 5 minutes to solve this one, and maybe after this one. First, I just want to know whether you have any problem where. And for those who do not have a problem, it's just that they cannot finish in 5 minutes, meaning you are still halfway through. Then that is an indication that you actually need to have a bit of exercise to polish, because this kind of question should take less than 5 minutes. As we mentioned, it is a small part of a longer calculation later on. If that is already take 10 or more minutes, then you will have big problem in your exam. And this should be just straightforward. Like 10 seconds. It's just like, of course, when you calculate another 10 seconds, of course. Now, for those who, that's the case for those who have, basically you know what's going on, what to do, but it takes a bit of time. For those who don't even know what to start just now, then that's even more of a concern where you really need to have more exercise to, because it's one thing to when you see someone else solve and you understand everything, and you actually know what to do when you do on your own, right? Because if you see a TV show or YouTube video of tutorial of how to build a rocket, etc., you might say, "Oh, I understand everything," but when you try to do it on your own, it's totally different thing. So similarly with solving a question, if you follow, then obviously everything makes sense and you understand. But that doesn't mean that when you rub off this one and you do on your own, you can, right? In the exam, it will test on that side. So make sure you do test on your own. So in 5 minutes, let's see how much you can do in this one. The steps should be the same. Alright. It's already 5 minutes. Of course, I think most of you will require more than 5 minutes because you actually spend some time to draw the question. But in terms of the solution, it should be only 5 minutes. Now, just to see, because I think from here until the end, you know what to do, right? But any problem is resolving the force into x and y? I think mostly no problem. For F1, you get 850 times what? 4/5 I, then minus 850 G. I think no problem there. For 6 to 5, so minus 6 to 5 sine, is it? Minus 6 to 5 cos. Okay. And then minus 750 cos or sine? Plus 750 cos. Okay, I know we have still any problem about sine and cos. Which one is different? Hopefully not. Now, one additional reminder. How we determine whether what you write is correct or not in terms of the methodology is it has to correspond to the diagram. Now, because some students actually, okay, well, first we go to the 45 degrees. Even if you make here cos and here sine, the answer is the same, right? Yes. But whether this is considered right or wrong is depend on whether the angle is, the drawn angle is, on which side. Because if it's sine corresponding to this one, is because this side, right? So if you write cos here and sine here, it will be considered wrong, even though the answer is coincidentally right. Now here some students actually they say, what if I use cos 60? Right? Because some students they do not know how to deal with this one, they consider this 60. Okay, right? Now if you want to do something like that, you have to redraw the diagram so that whatever you do have to match your diagram there. If you use this one, you have to use 30. Otherwise it doesn't make sense. What is this 60? What are you referring to? Right? So you have to redraw to say I want to use this 60. So then it's okay. It's consistent. Do you get the point? Alright. So if you have calculated this one, I think the rest is just you add all the x component and y component. In this case, you get negative value, right? So when negative and negative meaning it's to the left and it's downward, right? So you'll get something like this. So when you consider, for example, if you draw this one theta, then the answer is 72.6. Now, some question actually give a specific instruction. Express the angle from the positive x-axis, for example. Then you have to add the 180 and then you get this one, for example, right? So that depends on the question. But if the question like this, the question never indicate anything. So if you say 72.6 and then you draw this the angle, then that's okay. That's a complete answer already. Any question? Anything not clear? Okay. Okay, so if no problem, attention quiz. So for this diagram here, which will be the answer for the vector? If you resolve into x and y component. Yeah, C. Right, so x component is sine 30, y component is negative direction positive. Make sure you notice about the positive and negative direction. Right? What is one? if F1 is 10i plus 20j, F2 is 20i plus 20j, the magnitude of the direction of F1 plus F2 is which one? How do you get your answers? You get 30i plus 40j, right? And then whether you do Pythagoras or 3-4-5 ratio, you get 50, right? Okay, that's the end of this part. Now, for chapter 2, we have finished 2.1 to 2.4. We still have 2.5, 2.6, 2.7, 2.8, 2.9 here, right? For chapter 2. For this class, we are already towards the end already. Now, so in a sense, because of next Tuesday is a holiday, and chapter 1 and chapter 2 should normally should complete in the first 2 weeks. So because of the holiday, we are pushed back a little bit, right? So, but anyway, I think we will proceed because the next one will be 3D. Yeah, so we'll continue in the next class on Thursday, inshallah. So before that, any question? Anything else or what we have covered? As I mentioned in the first class, the assignment may not be announced, right? So tengok rezeki lah. Yeah. But of course, if because I haven't decided sama ada gaji atau malam tak buat. But if you suddenly have a quiz on Thursday next week, it should be easy lah sebab because it's only cover what we have covered, the type of question that we have covered, right? But if we do not have quiz on Thursday, we will have later. It will be more difficult a bit because it will cover more. So depend lah. I think we'll end it there. So any other question? Ada baik? Okay, with that, I think we can end the session. Assalamualaikum warahmatullahi wabarakatuh.